This is the F105 loudspeaker. Is it art, or is it just some technical formulas and numbers and so on? Or is it perhaps a combination? The idea behind the speaker is the art in this. It is an idea about the shape, about the small speaker, about the experience of a speaker that has a very special sound. This is the art. I will show you the speaker. I will show you how I designed it, talk about how I design speakers in general, and we will listen to the speaker compared to different speaker, so you can get some sort of an idea of how it sounds. On the sides there are some strange holes. They are for radiation control. We have the logo. We see the front panel. It covers the outer edges of the frames on the drivers, so it has this nice, neat appearance. The tweeter is a small dome with a very short exponential horn. It is covered with this cloth. The low-frequency driver is a conventional unit. It is meant to be a sensible speaker, where there is a balance between its purpose and the cost. So it's made of affordable, accessible parts, and the cabinet design is made to be as simple as possible. Sophistication is in the design of the speaker. The purpose of this speaker is to be a small speaker. It is meant to deliver a smooth, easy to listen to sound. Not like the F2 speakers, the larger ones in the dark, which you can't see. It is a floor standing speaker. The stand is integrated into the speaker. And here you can adjust the angle to accommodate for different listening height or listening distance. On each side we see the acoustics ports. They affect the radiation pattern of the speaker. Sound radiates through these holes. This sound is different in phase and time from the sound that comes from the front of the drivers. And then when this sound sums together, it cancels out when you move towards the side of the speaker. This changes the radiation pattern of the speaker. As you can see, I have set them up in room 2. Now I'm going to tell you a little bit about the requirements and what lies behind this. What is the idea behind a speaker like this? First of all, it is meant to be a small speaker that is meant to be a speaker that has an appearance that is easy to fit in to a normal living environment. The sound is supposed to be a little bit more smooth and lean compared to such as the F205 or the F2 speakers especially. It is from the beginning designed to be used with a separate bass system or subwoofers. I wanted to have some of the special characteristics of larger panel speakers built into the sound of these. And I also would like to experiment with radiation patterns that can make it easier to get good sound in rooms, so that you can place the speakers closer to the front wall. Not like this. Now we have 1.5 meters distance from the speaker to the front wall. That is very long distance. In most cases, in an ordinary typical room, it is not acceptable to place the speakers in the middle of the room. So if they can be placed closer to the walls, that would be an advantage. What creates this sound with the three-dimensionality and the characteristics of the three-dimensionality is the radiation pattern of the speaker. And to be able to do this, I need to have ways to be able to control and change the radiation pattern and shape it into exactly how I want to have it. And to be able to make it like this, it is modeled into a mathematical or physical system, an electroacoustic model, where the different parts, the radiators and the cabinet, the internals of the cabinet, the parts, the shape of the cabinet, the size and dimensions and placement of the ports is into this model, and then this is simulated to see the response of the speaker before it is built. So the design process involves quite sophisticated mathematical or physical modeling of the system and simulations. And then there is the shape and the shape and the design of the cabinet in itself. The visual that you can see is of course connected to this technical analysis with the simulation of the electroacoustic system. So the radiation pattern, how the sound distributes around the loudspeaker across the frequency range, that is the most important aspect, parameters, properties of a speaker that define how it sounds. Then we have frequency response. That is what people are obsessed about. They have to have a flat frequency response. Well, of course you have to have that. But that was something they were able to solve that in the 70s, in the 60s even. I have plenty of speakers from the 70s that have a more than reasonably flat frequency response on axis. And this speaker also has that. But in this case, where you have this special solutions for the radiation pattern with the ports on the cabinet, it is a lot more difficult to achieve that. So you have to rely on modeling and simulations before you start building the first prototype and doing measurements on an actual speaker. Because if you don't, it's a hopeless It's hopeless to get this right. Up on the top end there is a small lift around 15 kilohertz. It's due to the driver, and that is intentional to have it like this on this speaker. And then it is more or less completely flat downwards, down to around 100-120 hertz, where it rolls off naturally. This is a speaker that you actually can use without processing, because it rolls off naturally. So you can use it without processing with the subwoofer. Of course, that limits greatly the dynamic capacity, which is not that great to begin with. So you can't play that loud. But it will work reasonably well. The whole pattern around the whole speaker, both vertical and horizontal like this, and vertical like this, defines how the speaker sounds and the tonality of the speaker. So it's not enough just to be able to get a flat on-axis frequency response. You have to have control of the off-axis response as well. And it is the balance of this pattern and the frequency response at the different locations around the speaker compared to the on-axis response that defines the sound. And to be able to simulate this more or less accurately is a huge advantage. You can never achieve this by doing this try and fail method, by building the speaker and then see measure and okay, it's like this, then we build another one, it's like this. It's hopeless. It will take 20 years before you get to a result like this. So that's not a viable solution. So even though you can easily design the speaker using a calculator and formulas like we did in the 70s and 80s, the world today is quite different, with very different possibilities and tools. And we use these tools to achieve something that we think is better. At least it is different. If you're designing a standard typical box hi-fi speaker, it isn't that necessary to do such complex simulations. But if you design something like this, want to create something like this, where I have tried to achieve something special in the three-dimensionality of the sound, then you need to have a different level of knowledge of electroacoustics, modeling and simulations and dynamic systems. And when we speak about dynamics, this speaker can never play loud. It is not a speaker that has good dynamics, even at low volume, because speakers sound different in regards to the dynamics. When we by dynamics mean how transients like drums and so on is reproduced. They sound different. The F205 is quite different in that regard compared to the F105. But what if you don't want a speaker that can smack you in your body with the snares? You don't need that. You don't want it. You want a softer, more delicate sound. Then this speaker may be a better choice than the F205. When it comes to dynamics, there are two properties that defines this for the speaker. It's the radiation pattern, and it is also has the drivers themselves. In this speaker, there are very different drivers with very different characteristics from the F205. It looks like it may be something similar. It's a 5-inch low-frequency driver, like in the F205s, but that's about it. They are not similar in any way, apart from that. And when it comes to drivers, frequency response, crossover and so on, how this works, this driver is not an expensive driver, but it is a driver that has a very, very smooth frequency response. It is nothing like the drivers in the F205. The drivers in the F205 is like untamed sports car or a race car. It's a race car, but this is more like a tamed version of the same, not even the same type. It's something that is much more easier. You just, like a car, you just put yourself in the driver's seat and push the start button, and then there you go. It's very easy to work with, and it looks like it is perfect if you measure the frequency response. Of course it isn't perfect, because what causes this seemingly flat response is that the defects, the breakups and reflections and so on in the cone of the driver perfectly cancels each other out. Where the one failure causes a peak, and then you have another fail, causes a dip, and then it's perfect, it's flat. But it isn't. And those small what is left from those resonances and faults is what causes very audible loss in clarity and definition compared to the drivers in the F205. In the F205, the drivers are completely piston-like in movement and completely flat until it isn't anymore. It completely falls apart. So the F205 requires a very different approach in a crossover network. This, of course, makes it easier to make a crossover network. Frequency response, as you can see here, it's reasonably flat. And that is the specification, reasonably flat. And you see the off-axis response. The effect of the radiation control is very sublime. It's not very defined. It's not a true cardioid speaker, like a cardioid microphone, like that one. It's more like a normal speaker that is quite a bit larger than this one. So it has some effect on the radiation pattern, but it doesn't remove the sound that emits radiates towards the sides and the back. There is still sound around the speaker. You can see this pattern on the frequency response graphs I have here. Also, the sensitivity of the speaker is actually very low. It's 85 decibels for 2.83 volts signal in, and at 1 meter. And it's 8-ohm speaker, so it's very easy to drive for the amplifier. The crossover network, as you can see, it starts development as parts like this, or actually it starts inside this mathematical model in the simulation software, because the crossover network is also put into the model. I put everything into this, so I can see the effect of each component in the frequency response and response of the speaker in the simulations. So when I build the crossover network, it is mostly done, but I still make this mock-up of the crossover network, and then this is built into the speaker, and the speaker is assembled. It is now a prototype. This is prototype number 0. It will then be measured in various ways, and the tuning of the crossover like this is the final tuning of the loudspeaker. As you can also see from this, the speaker is not just a box and then you put some damping material inside and then it's finished. You see there are two sorts of damping material used on the sides on where the ports, acoustic ports are, and then there are parts of damping material placed inside the cabinet. And finally we see the finished version of the crossover network. It has some sort of a board so that everything is assembled correctly and mechanically rigid, so it doesn't fall apart after some time. And here you see the building process of the speaker. You see the different parts. Then it is assembled into a cabinet. And note that even the first prototypes, it's not really a mock-up that is meant to be scrapped after it is measured, because the simulations are accurate enough to know that it will work. But still, I don't know exactly what kind of sound will this speaker have before it is completed, and I put myself in a listening chair and put on some nice music and sit down and listen to it. That is when realize this speaker sounds like this. There are some characteristics that will be inherent in the speaker that will be impossible to change or remove. And then there may be characteristics that is easy to change, like the tonality. Is it bright? Is it dark? That is something that you can tune and change by doing changes in the crossover network. Of course, during this process of tuning the speaker and crossover network, there are measurements. And this is not the kind of measurements that you see when you measure a speaker for a review, for instance. I measure very close to the speaker. You can see here is the near-field response of the drivers, near-field response of the sound coming out from the acoustic ports. And then it is more far-field responses, and then there's the response around the speaker. And you have to do a lot of measurements, and during this process it is, if I had an anechoic chamber, that wouldn't be that really so helpful. It wouldn't save me a lot of time, because then you have to carry the speaker down to this chamber, do the measurements and back, so on. That also goes for devices such like the Kvalsvoll device. A Kvalsvoll is an excellent device to measure the speaker, but for this development purposes it is something that typically will be used in a very late stage. The speaker is completed. Let's see how it measures. Then it really doesn't matter if it's finished, it's completed speaker. The project is closed. Then you measure it with a Kvalsvoll and get all the data for the speaker. And you see here I build some more F105 speakers, several of them. And one pair was white. Unfortunately, this pair was sold. That is sad. But lucky for the customer, of course. Gets this nice sound. So, where are we now? We are approaching the moment where I place those into a proper position and we can have a listen with the recorder, of course. And we are ready to listen to the F105 speakers. And we are, of course, going to start with the Ole Miss. Now we have seen the speaker, the F105. I have recorded lots of samples. I don't know which one and when and if they are ever going to be published. Some of them are going to be in this video. That's the Ole Miss, of course. That one is going to be here. I have lots of other samples that show off, hopefully, the differences between the F105 speakers and the other speakers. The other speakers is then the F205, because that's the only one I have recorded. I am very curious myself to be listen to these recordings, to hear what the recording actually manages to preserve in differences between those two speakers. Because when you listen to them, they are clearly different. The difference between the F105 and a speaker like the F2 or the F205 is in the radiation pattern that gives a different presentation of the whole music, where a speaker like the F205 is very precise and renders everything very sharply defined. This speaker, the F105, it's made to smooth things out a little bit, but still be able to have a sort of a rendering of an image that so that the dogs and the cats are spread around in a soundscape. It's supposed to be a soundscape, not a flat soundstage. So then also, since this speaker is the F105 is much simpler in construction design compared to the F205, and there is a difference in complexity and above all cost. The parts in the F205 cost so much more. Some aspects of sound reproduction quality may actually come down to taste and how we want it. Then if something is different from something else, then it really isn't. We can't define one as being better than the other. It is different. In this that aspect, the F105 compared to the F205, it is different. But we have to be honest here and also realize that there are several aspects of the sound here that are different and clearly is so much better with the F205 that they are not really not comparable. That is also the cost of F205 is many times the cost of F105. But some characteristics here I think will be quite surprising. I have measured the frequency response of both systems with the recorder exactly where it is placed when we do these recordings, so we can compare things. But if the frequency response is equal, shouldn't the sound be the same? No, it isn't, because the frequency response isn't the same. Because the frequency response of a speaker is different when you move around the speaker. And it is all this sound that radiates outwards from the speaker that creates the sound. But the direct sound from the speaker, it comes first to the microphone and is dominant, especially in this room. And this means that the rest of the sound is then radiated towards the reflecting surfaces inside the room, and will be delayed. And the sound character is determined by the frequency response of the direct sound compared to this sound that is radiated throughout the room, and also the level of this sound that is radiated throughout the room, because that sound is delayed. And it's this that causes differences in perceived dynamics of a loudspeaker. When I designed this speaker, it is made according to a specification, and it is also made to have a characteristic sound. It isn't supposed to sound perfect or neutral, because perfect or neutral is what we have tried to communicate to you through this video, is that perfect or neutral for a speaker, that is not something that is exactly defined. It is relative. So it is different. The properties of the speaker defines then how the sound is perceived, and whether this is the perfect sound or neutral sound, that depends. Some aspects of it is clearly not something that is ideal or perfect. For instance, it's 85 dB sensitivity. That makes it impossible for this speaker to play loud. If you have a large room and want to play loud, it is impossible to achieve that with this speaker. But if you sit pretty close like this, and you don't need a very high loud volume, it's plenty, especially with the Gurion. So that depends on the use. Smaller room, moderate volume, no problem. Still, there are limitations in dynamics. The F205 sounds a lot more dynamic, even at a very low volume. Like attack on drums and so on, transients and so on, it kind of explodes in a F205, and that happens regardless if you play loud or very soft volume. It's the same. Then how do you design a speaker with character without introducing faults? And that has to do with knowledge and how you design things, how you work through the design process. But isn't it this misperfection that creates the character of the speaker? No, it isn't. The F105 has a flat frequency response, reasonably flat at least. What you define as flat, that depends on an amplifier. It's 0.1 dB on a speaker. That's impossible. So because if you have a DSP, a perfect DSP and a perfect microphone, so you can tune it to 0.1 dB one morning, when you go play this speaker late in the night, slightly different temperature, slightly it has aged one day, it will not be 0.1 dB any longer. So that doesn't add up. It's a physical, mechanical system. It isn't accurate enough. So we have a larger window for acceptance of deviations for a loudspeaker. Still, a loudspeaker that is not to be placed in a category as a defect design, has to be within certain limits. You can't have a horrible frequency response. You can't have resonances, large resonances, and strange behavior. And even later years we have seen very expensive speakers that have serious faults in their tuning of the bass system. They have faults in the crossover. There are faults in the frequency response. Of course, some of those faults you can fix in DSP, so you can fix the frequency response, but you can't fix everything, because you can't fix the off-axis compare. If you fix the off-axis, then the on-axis will be wrong, and if the on-axis is fixed perfectly flat, then perhaps the off-axis isn't good, so it doesn't work. That's why you see many of the most famous hi-fi speakers, they have measure, and the reviewers measure them. They say, "Oh, it's a flawed design because it doesn't have a flat frequency response." No, it doesn't have that because it can't have a flat frequency response. It has to be balanced against a defective off-axis response, and if the off-axis is defective, you have to balance that with other similar defects in the on-axis response. So you have a loudspeaker with a very strange frequency response. And it is made like this to make it work reasonably well. It doesn't work very well. It sort of works, because the tonality will be reasonably correct. As long as you have a room with reverberation similar to what the designer had intended. So if you place one of those speakers in this room, it will probably fail, because the early reverberation in this room is very short, whereas the long time, it's very long, as you can hear. Speakers can sound different. That can be due to choices made by the designer. Because this design a speaker properly, as we have learned here, it's not just to mock up something, especially if you want to make something that is out of the ordinary. There is a process, and there is knowledge and something behind this. And as we also hopefully will be able to hear in the recordings, it does actually pay off to do this work. But you don't need to build in technical defects in a speaker to make a speaker that sounds different. You can have a speaker that sounds different but still is technically not defect, and also it will sound good within constraints of this requirement specification that is made for that specific speaker. You can also say that a speaker such as the F205, it may not be preferred compared to F105. I can't really see how that could happen, but maybe it's possible. It has to do with the presentation and how sharply defined things are. In the F205, everything is very sharp. Perhaps you don't want that. There is a reason why people like vinyl sound, and that is due to a softening of the sound, which is mainly caused by dynamic compression of the higher frequencies. So it will sound softer and have more body to the highs, but it won't sound distorted, and it won't lack resolution. Whereas digital, with no compression, no changes to the signal, will then sound different. It will sound sort of very sharp, more precise, and kind of dead and hard. And it's a similar thing with speakers, especially high frequencies, when the radiation pattern is slightly more open and not so sharply defined as the F205, then it will sound softer. This will also affect the tonality of the speaker, so the F105 will tonally be judged as a darker sounding speaker compared to the F205. Even when we measure the frequency response, it is exactly the same. So this was my thoughts for a presentation of one of my speakers. I may present more speakers. We will see about that. I will look into presenting some of those recordings I have done.